Hello guys, so in this video we're going to be learning about vector stores in LangChain, vector stores. Before we go into code, as we always do, first I would want to show you what vector stores are all about. What are vector stores, what are they used for, and why are they important in LangChain? Why would we need to use vector stores in LangChain? So let's begin. First, vector stores are important. First, let me just write our topic here, vector stores. So vector stores are important because of a very popular topic known as RAG. Yeah, RAG. That's why vector stores are important, because they play a huge role when you want to perform retrieval augmented generation. Yeah, vector stores are quite important. So, but what do they really do? What do they really do? Now, retrieval augmented generation has to do with you picking context from your private documents or from known sources to be embedded into your prompt, so that your prompt has the factual and correct context on which the model can build a response. That is what RAG is all about, retrieval augmented generation. You are augmenting the retrieval you are augmenting the generation from the model by retrieving information from credible sources. But how is this information gotten? How do you get this information and how do you manage them? So the first thing you have to do is get your reliable source, let's say a web page or a PDF document. For now, let's just say a PDF document. So you have your PDF document. Let's say it's about your company FAQs. So you have your PDF document. And you want this PDF to be used as a source of information for your model. Let's have the model here looking like a brain. So this is our LLM. You want the PDF to be used as a source of information for the LLM to generate factual information, because the LLM is probably not trained on your company's data. So yeah, how would it be able to answer questions that your users will have? How would it be able to answer frequently asked questions? So you have a PDF and you want to use it as the source of truth. So what do? First, you have to get this PDF. You have to find a way to convert it into a format that your LLM is going to understand. You have to be able to convert it to a format that the LLM understands. Now, you might just think, oh, it's natural language processing. Shouldn't the LLM understand natural language? No, not really. Behind the scenes, your LLM is not working with natural language. It's working with vectors. Yeah, your LLM is working with vectors. So yeah, 101, 2, 1, 8, 4, 0, 3. Yeah, let's see that's an example of a vector. So every single thing, be it a word, a sentence, an object, an image, the LLM sees it as a vector and communicates back as a vector. This is then decoded into the natural language. So it's more like you encode your words, your natural language into vectors. The LLM processes it, it returns the vector response, and that is decoded, or rather, just encoded back into natural language. And that's what you get back. That's the response you get back. So for the LLM to be able to work with your PDF has to be represented as a vector. Yeah, it has to be represented as a vector. So you need to take this PDF and convert it to a vector form. You have to convert it to a vector form. Now, me having vectors like this is just an oversimplification. Vectors are more complex than this. But let's just assume that this is what they look like. So it has to be converted into a vector. And then this vector needs to be stored. It needs to be stored because this PDF contains all the information about your company. But when a user is asking a question, you don't want to retrieve all the information at once. So the first thing you just want to do is get this PDF, convert it into vectors, and put it here. Put it into this store. Now, the process of converting the PDF into vectors is known as embedding. Embedding. I'm sure you are very familiar with that word. Embedding. What it is converted into are called vectors. As we have mentioned, they're called vectors, and sometimes you can call them embeddings, meaning that you're embedding the data in vector form. So vectors, and where it is stored is what is known as a vector store or a vector database. Yeah, vector store, a vector database. So you want to take your information, your PDF, you want to embed it, that is convert it into vectors, which is what LLMs understand, and store it in a vector store. Then when you are to process a prompt, let's say a prompt is coming from here, I need to process the prompt, Then the prompt will first go into the store to get, let me do a proper arrow here. The prompt will first go into the store and get the appropriate documents that relate to what the prompt is talking about. For example, maybe the user is saying, oh, what is your refund policy? What is your refund policy? So you have all your company data already embedded into this database. The prompt says, what is your refund policy? So it goes into this store, does a semantic search to figure out which documents in this store are related to your refund policy. Then grabs those. They are mixed into the prompt. So they are mixing, the prompts are mixed, the retrieved documents are mixed into the prompt to create context for the prompt. And then that is what is now sent to your LLM. That's what is now sent to your LLM to process. So your LLM has information, actual factual information about your company, and it will then use that to generate the appropriate response back to the user. So that's basically how RAG works, and this is what vector stores do. You need a vector store to store those embeddings so that you can use them, you can retrieve them, package them with your prompt to then be sent to the LLM. So that's what vector stores are all about. Yeah, that's everything about vector stores. And in this video, we're going to be working with a vector store. In our previous video, we talked about loading documents. So if you are interested in how documents are loaded, we did that in the previous video where we loaded a PDF. So check out that video. Where we're going to be going a step further and using a vector store. In the previous video, we did something similar to that, but we use an in-memory vector store that comes with LangChain. But here we're going to be using a proper vector store. We're going to be using Chroma because I'm familiar with Chroma. You can use Quadrant, you can use Weaviate, but I'm familiar with Chroma, so we're going to be using Chroma. I love it. It's open source and it can work in memory. So we're going to be using that, and we're just going to demo this entire loading, saving into our vector store, and even the retrieval process. That's what we're going to be doing in this video. So now let us jump into VS Code and write some code. VS Code, I have a new folder opened up. I have a project folder created. It's called Vector Stores. That's how we're going to practice our vector store demo. So we have it is going to be a Python project. So the first thing we're going to do is to open up our command palette, VS Code, and create a new Python virtual environment. For the VMV environment, I'm going to be choosing the Python 3.11.6. I have that created. You can see our .vmv here. That's cool. Process is done. And now if I pull up my command line, you can see .vmv here, showing that we're now in the context of the virtual environment. So that's the first thing you do. That's the very first thing you do. Now, next, we're going to be installing some dependencies. Now, we're going to need LangChain. We're going to need LangChain because that gives us access to vector stores, vector store packages. We also need LangChain core, or rather LangChain community, because we need our loaders from there. That's where loaders come from. PDF loader, text loader, web loader. That's where our loaders come from. Then we also need to install LangChain core, but I believe if you install LangChain, that should just come with LangChain already. You need LangChain core, but LangChain core. Most likely it's going to come with LangChain itself. And we're also going to be installing the Chromadb. We're going to be installing Chroma. Chroma is our vector database for this demo. So we're going to be installing Chroma also. So in one single swoop, let me pull this up a little bit. Let's install these packages. So pip install LangChain, okay. Then LangChain community. Then LangChain core. Just specify it just for good measure in case it doesn't come installed with LangChain package. And we install Chroma. Chromadb. Yeah, that's the name of the package, Chromadb. So we install Chromadb. Like I said, Chroma is just one of the numerous vector stores that you can use to save your embeddings. There's Weaviate, there's Quadrant, and there's even pgvector. So if you're a Postgres fan and you just want to stick with that stack, you can just use pgvector. They have a vector store arm of their database. Let me just call it that. So yeah, or a vector store variant of their database. So pip install LangChain, LangChain community, LangChain core, and Chromadb. Let's hit enter and watch that install. If it takes a while, I'm just going to come back, but it might just complete before I finish talking. And while that is installing, you will notice we also have a file here called LangChain underscore txt, which is a text file, LangChain underscore details rather, .txt, which is a text file. If I open that up, it's just a simple text file that contains some information about LangChain. LangChain is a framework for developing applications powered by large language models, and there's some other details like that. So why do I need this? I need this because this is what I'm going to be loading. This is the document I'm going to be loading. So I just want to use a simple text file. We get to use a text loader to load that in. And this is what we're going to query. Yeah, this is the document that we're going to query. And just as I predicted, before I finished talking, this was done installing. So everything is installed now. Let me clear the screen. And yeah, can close out of this file. So this file, this is where we're going to be loading information from. This is what we're going to be loading into our vector database, and we're going to be retrieving from. So let's close it up and let us create our Python file. For our Python file, I'm just going to create a file with the name vector search with Chroma. Vector search with Chroma, let me say Chromadb. Vector search with Chromadb.py. So here we have our Python file, vector search with Chromadb.py. And the first thing we're going to do, let's just close out of this command line for now, is to bring in our dependencies. The first thing we're going to bring in is our text loader. And that is going to come from LangChain community. It's going to come from the document loaders package. And we'll say import text loader. We have a text file, so we need a text loader. Next, let us bring in our Chromadb wrapper. We'll say from LangChain community dot vector stores import Chroma. So that gives us the Chroma class that we need to work with our Chromadb. You're working with a different database, be sure to change this. Yeah, after these two, yeah, we also need one more thing. We need LangChain OpenAI, and I've not installed that because we need the embeddings model from OpenAI. So let me pull up my command line once again. Let's do pip install LangChain OpenAI, and just for good measure, also install the OpenAI package. Now, why are we bringing in LangChain OpenAI? We need an embeddings model to embed our document into the database. We need it to embed. We need it to convert our document into embeddings, and those embeddings will now be saved in the database. And this is very, very important because the same embeddings model or function that you use to embed into the database is also the same one you use to retrieve. It's also the same one you will use to retrieve it. So you can't use a different embeddings model to embed your information into the vector store, then try to use a different one to. You can't do that. Even though from the wrappers that LangChain provides us, most of those things are done, especially the retrieval part. Once you've created your embeddings with a particular model, when you want to retrieve, that is what the retriever is going to use. So there won't be any confusion there. For a vector store like Chroma, it actually comes with its own model that you don't actually need to use the OpenAI model. It comes with its own internal model that is around like 80 to 400 MB for you to download it onto your system. So not too crazy. So it just uses that to do its embeddings. But in this demo, we're going to be very, 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 very explicit by actually using OpenAI's embeddings to embed our document. So let's bring those in. Let's say from LangChain OpenAI, we import OpenAI embeddings. OpenAI embeddings. So that's good. Another thing we're going to do, now this is not really compulsory, but let me just bring in the package first. From LangChain, let us get our text splitter. And from our text splitters module, let us import the recursive character. These things can be very tricky to type. Recursive character text splitter. Recursive character text splitter. Now, why would we need a text splitter in this scenario? Most of the time, you're going to be handling large documents, whether you're loading from the web, whether you're loading from a database, or you're loading from text or a PDF file. So imagine a PDF file that has 300 pages and you want to load from that. Now, that is big. And you can't just carry that and dump it into your database. So what a text splitter does is that it splits the content of your document into different chunks. It splits them into chunks. And that way, it will be easy for them to be stored in the vector database. And it will also help with all the semantic mapping that has to go on with the database. And one thing you can also do, which we're going to look at later, is that for each chunk, you can specify an overlap. Because sometimes you lose context if a chunk just stops abruptly at a point and the next one continues. The one that stops abruptly doesn't have closure. The one that starts with immediately from the middle doesn't have context. So you can define an overlap. That will make sure that part of the previous chunk flows into the next chunk and vice versa. But we're going to see how that is done later. So we have a LangChain OpenAI installed now, and we can continue. So I think these are all the dependencies we'll need. So let us start with step 1 of working with our vector database. And the very first step is to load our documents. So we need to load our documents. So I'm just going to put a comment here and say load documents. And first, let us define our file path. Let us know where we're getting our document from. For this, it will be LangChain _details.txt. That's our document. LangChain _details.txt. Make sure that you spell this correctly. Very, very important. So we get our file path. I'm going to be putting some interactive comments around here just to make it easy for us to follow along with the process on the command line. So we're just going to print here. I'll use fstring. We'll say loading documents from, then we'll just say file path. Loading document from file path, Okay, so in our console, it's going to indicate that is what is currently going on. So what we basically do here is to get a loader. If you watch the last video, you'll know what a loader is all about. So we'll use our text loader. We'll give you the file path. And from here, we can then get our documents. And we can get that by calling the load function of our loader. Yeah. So now we've loaded our documents. Get our documents, we load them. Step 1. Now the next step is going to be to split our documents into chunks. Let me number these steps so that it just makes them cool some way. So we load our documents. The next thing we're going to do is to split our documents. Like I said, this is important for large files, which is going to be most likely what you're going to be working with. But for this particular LangChain details txt, it doesn't really matter. But let's just see what this does. So here we can say print splitting documents into chunks. Then here, what do? We simply say text splitter and set this to our recursive text splitter. Now I don't want to type that all over again, so I'm just going to grab it from here. So recursive text splitter, and we tell it that we want a chunk size. That's the size of each chunk to be 500. I think it's 500 characters. Yeah, 500 characters. Yeah, 500 characters. Then chunk overlap. The chunk overlap should be 50. So overlap 50 from a previous one into the next one and vice versa. So chunk overlap 50 so that we maintain context as much as possible. Then we can then get our chunks by calling the instance of our text splitter. Text splitter dot split documents. And we pass it our documents. So it helps us split these documents. It helps us split these documents. So that's cool. We're done with splitting. The next thing will be loading it into our vector store. Loading into our vector store. And first thing, we first have to prepare our vector store. So let me just write this step 3 and say set up vector store with documents. So our vector store, we're going to instantiate our vector store and we're going to set it up immediately with our documents. Now, there's a way you can just set up your vector store and it will be empty. There's a way to do that by just calling Chroma and creating a new instance. But we're going to be setting it up directly with our splitted documents. So let's go ahead and do that. First, I'm going to say embedder. I'm going to get my embedder. And my embedder is going to be OpenAI embeddings. I'm also just going to copy that so that I don't misspell it. So the guy that is going to be doing the embeddings for me is OpenAI embeddings. So you call the constructor. You can pass in a model here if you want to be very, very specific about the embeddings model that OpenAI should use. But I'm cool with the default, so we'll just go with this. Then we set up our Chromadb. I'm going to say vector store equals Chroma. And because I want to set it up immediately with the documents, I'm going to call the from documents method. And then we can start filling in some arguments. And the first is going to be our document. So which documents do you want to set up with? Set it up with my chunks. And which embedding do we want to use? Well, that will be taken care of by this embedder that comes from OpenAI. Next, what is the name of the collection? Now, collection is a Chroma thing. The name of the like a database, the name of the database you want to create, or the name of the table you want to create. So my collection, it should be like table. Like we're talking in relational database terms, it should be table. So just call it LangChain collection. LangChain collection. And what's the name of the database? What should be the name of the database? The Chroma database. I'm going to say persist directory. Persist directory. So it's actually going to create this database inside our code. I'm just going to call it my Chroma _db. My Chroma _db. So we set the persist directory argument, and we tell it, yeah, all my database information should be saved in my _Chroma _db at the root of the project. So this is good. Now, this might not be necessary in some use cases. This is just for when you want to persist the data, so that when you run the application, you still have the vector database active. But if you just want it in memory, you can just, if you ignore this, it's going to just have it in memory. It's going to run the entire thing in memory. So we have our vector database set up with our documents. So we're good on that part. We have our embedding function, making sure that as the chunks are coming in, they are being embedded. They are converted into vectors before they are stored. And now we can proceed to our fourth step. Step 4, which is to search, which is the fun part. Let us search our document. Let's perform a semantic search. So first, what would we like to query the database? Let's say query equals, let's ask it something like, what are the main components of LangChain? What are the main components of LangChain? Let us ask it that question. We know that if we check very well, it says the LangChain framework consists of several parts: LangChain core, LangChain community, LangChain Python, LangSap, LangSmith. So we expect that to be our result. But let's allow it to do it itself. So I'm going to do another print here just to make things more interactive. Let's have a new line and say performing semantic search for query, for the query that we just specified. Okay, performing semantic search for query. So that's good. Now let's get our results. Say results equals vector store. Now, the retrieval functions have different types of function that you can use to search, that you can use to retrieve. But we're going to be going with similarity search. We're going to go with similarity search. But if you look at this, there's similarity search, which is the one we want to use, which is a semantic search. There's similarity search by image, meaning that you can search with an image. Because you can also embed an image. You can embed an image into your vector stores also. So you can search with an image. You can search by vector. You can search by vector, meaning that instead of using a natural language query, you can actually use a bunch of vectors to search, and that can give you some performance benefits and stuff like that, or make things really, really direct. You can also search with relevant stores, image with relevant stores, vector with relevant stores, and even the search with relevant scores, meaning that it can tell you how relevant each retrieved document is to the query. You can score them, so you can use that to pick based on the requirements of your application. But we're just going to be doing a similarity search. We just want to see what this thing does for us. So we'll pass in the query. Another thing we can pass is a k parameter, which is basically like a sampling parameter that gives us the top results. How many of the top results do we want to get? Because sometimes we can return up to 20 similar documents to what we want to search. So you might say, okay, I want to pick the top 2, I want to pick the top 3, I want to pick the top 5 or the top 10. I think if you don't pick, I think Chroma returns top 10 by default. We're just going to pick 2. This is a very small document, and come on, the top 2 should be okay. Else, you just pick the entire document. So pick the top 2. That's good. And now let us print our results. I'm going to say print. And then we put a new line here and say search results. Yeah. Put a colon there. Then I'm going to say for I doc in results. But let me make sure that I have something I can loop over. So I'm going to say enumerate results. Good. Then we can loop over this. The first thing we're going to do, we're going to print. Like I said, we're going to have a lot of fancy prints here just to show how our result looks like. So say result. This will be the index plus 1 so that we can know which number this is in the result set. So we print that. Then we get the source of the information and the metadata. This might not be very, very important in searching a text document, but when you're searching a PDF, this can be very, very important. And also when you have multiple documents that you loaded into your vector store, it can be able to tell you, okay, yeah, this particular document that I got is from this file. This particular document that I got from, because you can actually store multiple PDFs. You can store multiple PDFs, multiple images. So getting the source is going to be really important. It will not be much for this because it's just the same source. But when you're working with in a complex setup, definitely you want to get this. So say doc.metadata, because each document comes with a metadata. Dictionary, we say get. So get us the source. And if you cannot find the source, just return not available. Yeah, just return not available. If you can't get the source, just return not available. We're fine with that. And then the main thing, print the content of the page. So we say content, and that will be doc.page content. And we're just going to pick the first 200 characters of each page content. That should be good. And right after all this, I'm going to print some dashes to just demarcate stuff. So let's just print like 45. Yeah, just print some dashes to just demarcate each retrieved document from the other. So yeah, this is the completion of the process. Before we run it, let's take it from the top. So the first thing we did was that we loaded our documents, just one document. We loaded our LangChain _details.txt file. We used our text loader to get an instance of a loader. And to retrieve our documents, we just called the load method. So it loads it into this document variable. Then we split our document, which I said is mainly useful when you have big files like PDFs with hundreds of pages and stuff like that. But for this, it's not really, it's an overkill. But yeah, at least we got to see how it works. You can define how many characters or size of each chunk and also how they should overlap to maintain context. Then we set up our vector store with documents. This is by creating a new instance of the Chromadb and giving it our documents and also the embedding function. We also specified what our collection should be for this particular document set, and we want it to persist it. So we actually want to see the vector database created on disk. Then we search, and we search. This is something that will happen later on within your application. The first 3 steps is more like initialization steps. They are initialization steps that you do maybe when your application loads or just towards the running of your application, but it's not something you keep repeating. But this search is what you do a lot when the user is interacting with your application. You get to do a lot of semantic search that queries the vector database. So we set our query to be what are the main components of LangChain, and then we get the results by performing the similarity search on the vector store. This uses the vector store's retriever to get the results for our query. We told you that we want the 2 most relevant documents, just the top 2 results. We don't want the rest. And we print our results, which I expect to just be 2. So let's run this. First, I'm going to pull up a command line, clear it. Now, the first thing we need to do is to add the key for our OpenAI, for our OpenAI API key, because we're using OpenAI embeddings. So we're going to be adding our OpenAI API key. That can be done by saying export OpenAI API _key. And you set this to your API key. And this will make your API key active in your current terminal session. But if you want it to be persistent, add this to your zish RC file or your bash RC file. Or if you're using Windows, just add it to your environment variables and it will be active. Now I'm going to be adding this off camera. So I'll be right back once I have added this API key. So now that I have added the API key for OpenAI, we can run our project. We can now run our project. Let me pull this up so that we can have enough room for the command line. And let us run Python vector search with Chromadb. Vector search using Chromadb. Let's hit enter and hope that the demo gods are on our side. Don't see any errors. Once it starts printing stuff out about loading our documents and stuff. So now it's loading documents from LangChain details txt. Now it's splitting them. It's performing semantic search, and boom, the results are out. The first thing you will notice if you come here on the file explorer, you can see that we have a Chromadb here. So my Chromadb, so that was actually created as we specified. Now let's take this from the top. So we say Python vector search, yeah. So we do that. Then it says it's loading documents from LangChain details.txt. It's splitting it into chunks. Then now it's performing semantic search for what are the main components of LangChain. That's our query. And these are the results. It gets 2 results. The first result is the one that says the LangChain framework consists of several parts: LangChain core, LangChain community, LangChain Python. Like I said, that is the main one that answers the question. If we open our file, let me bring it down. This is the main part that answers the question. So that is what it put at the top of the results, because that's one that has the highest probability. And because we told it to return 2, it also returned another result that says LangChain is a framework for developing applications powered by language models. It enables applications that are data aware and blah, 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 blah. So I think that comes from here. That comes from this top here. Yeah. It enables applications that are data aware and agentic. So it says that, yeah, this can also relate to your query. So you probably need that too. But the top result is the one that breaks down the several parts of LangChain into LangChain core, LangChain community, LangChain Python. Because we only queried for 200 characters, it stopped here. So we had the ... kind of truncated there. But if you look at the full thing, which is what you would get definitely if you're working in production, this is just for display purposes. If you're getting the full thing, it's probably going to pack up all these guys and return it to your prompt to then be packaged as the context for your prompt that will be sent to the model. So that's how you work with vector stores in LangChain. And I hope from this video, you've gotten a good understanding of what vector stores are and how we can use them in LangChain. Now, you may have noticed on these videos, you keep saying langcast.com. Now, langcast.com is the home of the best LangChain tutorials. The best LangChain tutorials will teach you to understand LangChain, and also not just LangChain, but AI engineering in general. So hit the link, langcast.com. If you see a coming soon page, it's still us. So enter your email to subscribe so that you can know immediately we launch. We're going to be launching around June, so yeah, not so long. So just keep a tab on us. Subscribe with your email so that you can know exactly when langcast.com is going to be officially launched.